Alrighty, so in this section, we're going to talk about variation, okay? And there's more than one kind. Direct variation is the most basic kind. So when you see direct variation or one variable varies directly with or as the other one, then you know you're going to be working with the basic function or equation formula, y equals kx, where k is what is called the constant of variation. Okay, so I'll write that down. K is constant of variation. That's just what we call it. And it operates a lot like slope. Okay, so I see, suppose that y varies directly with x and y. So boom, I see that. I see varies directly with it. So I'm thinking y equals kx, and therefore that's going to be the tool that I work with for this problem because of the underlying stuff. So it says, hey, when y is 4, x is 20. Okay, so I plug in 4 and 20. I divide by 20, and I get k is 1/5. So I can say, so if k is 1/5, then that means that y equals kx is, for this problem, is actually y equals 1/5 x. Okay, because I can replace the k with 1/5. So that's the answer to part A. Okay, y equals 1/5 x. So what about the answer to part B? Part B says, hey, you know what? It's really wonderful to come up with that equation, but if you never use it, what's the point? So in part B, they say, well, what would y equal if x were 9? Well, that would be, I don't know, 1.8. Now, they're not giving us any units like feet or donuts or anything. So it's just going to be 1.8, and that's it. All right. Or you can leave it 9/5, doesn't really matter. But that's the idea right there. Again, because it said varies directly, I know I'm using the equation y equals kx. We'll see another one here, different one in just a few moments. Now we'll do the same thing, except this time there's a story to go with it. Okay, hey, who doesn't like a good story? For a moving object, like maybe a hot dog being thrown through the air, the force acting on the object varies directly. Oh, there's my key words right there, with the object's acceleration. Okay, so we know we're thinking the pattern y equals kx because I see varies directly rather than varies in some other way. Okay. Okay, so before we move on to the second sentence, let me give you a little hint here that helps. I wish my teachers had told me. Whatever comes before that phrase varies directly, or the phrase that describes the variation, whatever comes before that, that is going to replace your y. That's your dependent variable. Well, the quantity that comes before it is the force. Okay, so that comes before it. And then whatever comes after it, like acceleration, that's going to be your independent variable, like x. Okay. So F equals Ka. Force equals K times acceleration, which, if I recall correctly, is mass. That's the answer to it. Okay. So when a force of 12 newtons, I don't know what a newton is or an N, but it does say that this is a value of force. So I'm going to plug that in for force. Okay. So 12 acts on a certain object, then the acceleration of the object is 3 meters per second, or 3 meters per second squared. So yeah, maybe you don't understand that guy either, but you don't have to. Okay, the point is, this force goes with this acceleration. They match up, they go together. So when I plug in one of them into the equation, I got to plug in the other. So I'll divide both sides by 3, and I know that K is 4. Now we could talk about the units of K if we wanted to. It would just be, newtons divided by meters per second squared. Those would be the units. All right. So that tells me right there that not only should I change colors because it's fun, but in my equation here, I know that K is 4. Okay. So now let's actually get to the last sentence. If the acceleration of the object is 5 meters per second squared. Okay, so that 5, that is acceleration. So if acceleration is 5, what is the force? Well, it's an energy field that connects all living creatures. It surrounds us, binds us, connects the galaxy together. Well, yes, I was 6 years old when that movie came out. Okay, let's see. So the force is going to be 20 what? Well, the units of force a moment ago we saw were newtons, so 20 newtons. Okay, and that is how you do these. So you start with an equation because it's going to vary directly because, well, that's what the instructions say, and then you plug in the numbers that they give you so that you can solve for your constant of variation, your K. Then once you've got that, then actually solve the, figure out the thing they actually want you to get. I like those kinds of problems. Well, I said that it's not always going to be direct variation, and so it isn't. There are two main ones that you see. This one is varies inversely. So when it varies inversely, your basic equation is not going to be y equals k times x. It'll be k divided by x. That's the only difference. Instead of multiplication, you got division. And it represents a different situation. When it's direct variation, and you have something like this, well, as x gets bigger, so does y. And as x gets smaller, so does y. But when you have inverse variation, as x gets bigger, y gets smaller, it does the opposite. And vice versa. As x gets smaller, y gets bigger. So that's the main idea. There's a little more to it, but that's kind of it. Okay, so it says go write an inverse variation equation. Okay, when y is 9 and x is 2. So because I see varies inversely, that tells me, oh, it's k divided by x. All right, so if I multiply both sides by 2, I get k is 18, and that's the answer to part 1. Okay, or part A, I guess. Part B, hey, well, oh, wait, no, that's not the answer. I lied. Rats. Okay, I didn't read the whole question. I need the actual equation. So the actual equation is going to be y equals our k value of 18 over x. That's the answer. Okay, sorry about that. Okay, now part B says, okay, cool. Well, what's going on when x is 30? Well, when x is 30, y is 18/30ths. Or I could cancel a 6 out of the top and bottom, and I get y equals 3/5, or 0.6, or 60%. 3/5 will be just fine. And that is what you do. So it's just like that first topic, except instead of, that one was direct variation. And so instead of multiplication, or instead of division, we were using multiplication. That was really the only difference. So now, of course, we do an inverse variation word problem. In an electrical circuit, the current passing through a conductor varies inversely with the resistance. All right. So if you're like me, you see resistance and you're thinking Star Wars episodes 7, 8, 9, but that's not what this is about. So like we said before with the direct variation, whatever comes before your phrase establishing the type of variation, whatever comes before it, in this case, the current, that's going to be like our y in y equals k over x. I don't remember the variable for current typically, so I'll just use C. I think it's I or something. I think it is. And then whatever comes after varies directly or varies inversely, that's going to be our independent variable, like X. So R for resistance. So what C equals K over R. That's going to be our equation. All right. Now, suppose that when the current is 28, okay, so 28 for C. So I'm going to replace the C with 28. The resistance is 5, so R is 5. If I multiply by 5, I get K equals, let's see, it's 140. Okay, cool. And yeah, so that tells me that my equation is Y, or no, not Y, C equals whatever K is, 140, divided by R. So there, we figured out for this circuit what the constant of variation K is. So now we've got what we need to work on this circuit and do different things with it and troubleshoot it, whatever needs to be done. Okay, so in the last sentence, it says, what's the resistance when the current is 10? Oh, okay. So if the current, C, is 10, what is R, the resistance? Well, I'm going to multiply both sides by R so I don't have a fraction. So I've got 10, R is 140. Then I'll divide by 10. And I get R is 14. 14 what? Let's see. R is resistance, and resistance is measured in ohms. Okay. Named after a famous German scientist, as I recall. Anyway, and then that's it. Again, very similar to that second topic in this video. The only significant difference is it's K, or it's division instead of multiplication. That's the only difference. Nothing else is different. Okay, so we've seen kind of the basic versions of variation. Formulas, variation models, whatever. So now we kind of mix it up just a little. The good news is that your answer is just going to be the first formula you write down. There's not going to be any evaluating. So on this one, it says U, okay, so U varies directly. Oh, okay, so that's K times. Varies directly with what? With the cube of P. Ah, all right. Now, if it had said cube root, then it would be like that, but it didn't. So the cube of P. And it also varies inversely. Oh, inversely means divide. With D. And I'm done. That is the end of the problem. So maybe we should try another. Okay. So let's see what we got here. Okay, on this one, D varies directly, so that's multiplication, with W. And inversely, so that's division, with P. Done. Yeah, I think these are kind of nice, fast. Okay, what else we got? Let's find something better. Sure, what the heck. Okay, so D varies directly, so K times, with the square of W. Boom. Done. All right, this one's a little different. U varies jointly. Oh, jointly, that's different. That's not directly, it's not inversely. Well, we know we got to have a K because we're doing variation, and that's the constant of variation. So varies jointly with P and D. What that basically means is I've got two variables that vary directly with U. So it's going to be K times P times D, and inversely with W. That is how that one works. All right, so let's take that last topic and sort of, kind of do a word problem with it. Okay, so the volume, Oh, wait, I gotta turn on my pen. All right, so the volume of a fixed amount of a gas varies directly, so K times, as the temperature. I know the wording is grammatically is a little peculiar, but that's the way it is. And inversely with the pressure. Okay, so suppose that the volume, I better change colors, that's kind of hard to see. Suppose the volume is 160, or when it's 160, the temperature is 320, and the pressure is 12. Okay, go find K. So if I multiply by 12 over 320, so that those cancel and those cancel, then, is that the right color? Yes, yeah, I think that's the right color. Okay, then give me a second to type this into my calculator. Then I get 6, okay? Okay, so, cool, so that tells me that my formula, oh, let me change colors again because it's fun, is going to be V equals 6 times T over P. So just took my formula and plugged in the K. All right, so I think I'll stick with that color. I like it. Makes me feel warm and fuzzy inside. So it says, hey, when T is 240, yeah, go find the volume when T is 240 and P is 16. Okay, that sounds pretty special. Okay, so 6 times 240 divided by 16, and I get 90 even. And the volume is measured in cubic centimeters, cc's, so 90 cubic centimeters. All right, cool. And then that's the end of the problem. That's what we're looking for. Now, on this one, we could have talked about the units of K and said, all right, 6 what? Well, what did we do to get K? Well, K is this stuff multiplied together. Okay. More specifically, it's the 12 kilograms per square centimeter. Whoops, that's 2. Divided by the 320 Kelvin. That's a temperature measurement. And then multiplied by that 160 that had units of, where's the 160? Oh, cubic centimeters. All right. And it turns out all but one of those centimeters over here cancels, and then you end up with kilograms centimeters, that's a hyphen, per Kelvin degree, per degree Kelvin. Anyway, yeah, it's like, okay, how do I visualize that? I don't know. But anyway, I mean, you can explore that. It's worthwhile to explore, but that 90 cubic centimeters, that was the answer. This stuff over here, I was just throwing that in extra, just get you thinking about some good stuff. And that is it.